Hello everyone, my name is International. Today I'm happy to present to you a work I did during my PhD at IRISA and completed during an internship with Pedro Lopez at the University of Chicago. But to begin with, I want to show you a video that illustrates a hypothetical but plausible scenario based on the results of our study. So here we have someone who is playing a game in VR when suddenly fire alarm rings and the users remove headset to try to reach for an extinguisher. However, surprisingly, he turns the wrong direction. In panic, he tries to reach for the alarm button to deactivate it, but again he fails and misses the button. So what happened here? And why did I tell you that the result of our research can explain this? Everything you saw, we called it a VR side effect. These side effects that I'm talking about go beyond the usual ones you might already be sick about, such as cyber sickness, eye strain, fatigue. Today I want to talk about an unintended lingering adaptation leading to potential risks after leaving VR. But first, let's dig into the work motivation. So most of the VR works in ACI, for example here at UIST, focus on how the plasticity of our brain allows us to adapt to VR, leading to more immersive experience and interactions. For example, here the user is convinced that his real hand is actually at the position of the virtual hand, which is called haptic retargeting. But today I'm not really interested about this. I want to about how you adapt into VR. Instead, I want to focus on what happened after, when you go out of VR back to the real world. Is the readaptation instantaneous? Does the sensation that develop in VR completely disappear instantly? Or might it be that something still remains, that my perception stays to some extent attached to the real world? To answer this question, let's start with the insight offered by previous works. There's quite much works in VR that focus on how VR can have a positive effect on the users, even unconsciously, for example, skill acquisition, tracing behaviors. But there's some works that started to turn their attention on the potential risks that VR adaptations could bring to users, such as through movement alteration to fall or collide with their environment, but also memory alteration that leads, for example, to misremember a place or a scene. However, this remains mainly speculative and therefore will require validation from empirical results. There's some works that already have started to measure movement and memory effects, but only in very constrained settings. For example, forcing users to wear blindfold after exiting VR, or telling participants ahead of time to focus on remembering virtual objects. These are really insightful, but they do not really allow us to definitely conclude on these risks. For example, whether unsuspecting participants with modern headsets could experience side effects after leaving VR. So to answer this question, we conducted two user studies. The first one was about movement side effects, which is a type of VR side effect that could occur after experiencing a movement manipulation technique in VR, such as haptic retargeting, which I mentioned earlier. So in this study, which might seem a bit familiar if you attended Martin's talk just a few minutes ago, participants performed back and forth movements in VR. They were presented to different amplitude of movement retargeting, either with low gain, which is a movement that the alteration was unnoticeable by the users, high gain, which was twice above participants' recognition threshold, or no redirection at all, which was used here as a baseline. After each condition, after recognition of movement in VR, participants were then asked to remove the headset and reach for a target in the real world. And so what we measured was the difference between the fingertip and the target. Here you see the first time when participants go out of VR and try to reach for the real target. Without any hand retargeting in red, they were just 1 centimeter away, so pretty close from the target. But with a noticeable low gain retargeting, they were already 3 centimeters away, which is much more, and even more with the high gain retargeting. However, in the study I didn't tell you yet, but we did not ask participants only to reach for the target 1 time. We also asked them to repeat this process 10 times. And as you can see here, we actually found that even if it decreased in intensity, these effects still occur pretty strongly even after several repetitions. It actually takes about 9 repetitions to completely come back to baseline. Overall, these results show that movement adaptation in VR can linger out of VR. It also explains our hypothetical scenario that I presented earlier, where the user missed the alarm button, which was actually due to an earlier presentation to this movement redirection in VR. Now let's switch to our second study, which is focused on the risk of memory side effects. which is a type of VR side effect that consists in the confusion between real and virtual memory. Here we measured how much participants' memory of a real room could be altered by the presentation to a modified version, a virtual replica of this room that presented objects that were removed or added, but also contrary to other studies with position and attributes that were modified. Specifically, participants were first presented to the real room, which they explored for 4 minutes through a searching task. Then they were split into 2 groups. In the first one, the side effect group, they were correcting the same task again, but in a modified replica of the modified replica I introduced you before. And in control group, they played a puzzle game in VR in a completely different scenario, completely different environment. Then participants got out of the room, and they were kind of expected to fill a sort of classical questionnaire about their virtual experience. But we handed paper to them, and we asked them to recall the real room. So the position, presence, absence, attributes of the object in the real room. And I want to emphasize that they did not know at all that was the objective of this, the memory was the objective of this study. And in fact, some participants were pretty confused why we were asking them that. But let's observe the result of the study. Here I will focus mostly on the position result, as they were the most visible effect on the participant memory. Let me start by explaining how to read the figures in this one specific example related to extinguisher. These red dots represent each responses from participants in the control group when they were asked to remember about the extinguisher position. This C represents the average position, and here we have the position of the extinguisher in the real room. As you can see, there is some uncertainty obviously, but there's a solid amount of participants who in the control group remember the correct area. But now, more interesting, these blue dots represent each response from participant, this time in the side effect group. So those who are presented to the altered room replica in VR. Here you have the average, and in fact this result tends to be closer to this point B, which is the position of the virtual extinguisher, where it was placed in the virtual replica, in the virtual room. Here you have a typical example where participant memory seems to be biased, drive toward the visual experience, the virtual object in VR. Here you can see the result of the 6 object measure, and we can note there's some that exhibit some sort of side effects. And finally, we can explain the second part of our hypothetical video, where this user misremembered the extinguisher, if you remember. The reason was actually he was just seeing a virtual extinguisher at a different position in the virtual environment before. So to conclude, we studied the concept of VR side effect, which we define as an unintended lingering adaptation leading to potential risk after leaving VR. In the first user study, we showed that adaptation to movement retargeting could linger after leaving VR, which can provoke different risks of collision, for example. In the second user study, we also showed that VR side effect could also impact memory, leading to users to misremember the position of real objects saw in VR. So what can we do about it? In the paper, we established a call to action for the community to better address and understand these different risks. For example, to include different strategies that could help fading out the different side effects before coming back to the real world. Also imagine that we could label the side effects the same way we label drugs with their possible effect size and danger. So I need to check out for more in the paper, and that concludes my talk. Thank you so much for your attention, and I'm happy to take any questions.